Good afternoon. The Apollo guidance computer was instrumental in bringing men to the moon in the 1960s and back. It handled everything from orbital insertion around the moon to transposition and docking, the barbecue rolls, landing on the moon, taking off, orbital proximity operations, firing back to Earth, and getting the right angle for reentry. It was absolutely critical for its success. There were 2 Apollo guidance computers flown on each mission. One was in the command module, which is here, and the other one was flown in the lunar module, which is there. The Apollo guidance computer was a miracle of modern engineering. It was the first computer to use integrated circuits, chips, 3 input NOR gates. The whole thing was built out of that. It had 15 bits of address space, which is, 8-bit computers were normal in the 80s. This was running 15 bits in the 60s, so pretty impressive. Each one cost $1.5 million in today's money to build, so not so impressive. And it came with a whopping 4 kilobytes of RAM. The input-output was handled by something called the DISCI. You've got a numeric keypad, and then it can display 3 5-digit numbers, as well as a few other status indicators. That's it. They don't even have decimal places. That's why astronaut training was so important, because you needed to know what that number represented. As one would expect, this computer was programmed using its own assembly language. There's a joke that is passed around in the United States that there's 2 types of countries in the world: those that use the metric system and those that have landed a man on the moon. Well, that joke gets a little bit hollow when you look at the code. All math in the AGC is done in metric, and then it's converted to imperial for the astronauts. It's a bit challenging to program because everything's in octal, and the assembly language is completely unrelated to anything we use today. The overall concepts are the same, but the language is completely different. So there's a bit of a learning curve. So I did the obvious thing, which was to make it easier to program the Apollo guidance computer. We will use Blockly. So if we, here we go. Let's see, count down from 5 to 0, and then we'll display the digit, and then we'll wait for 1 second, or rather 100 centiseconds. Anybody used centiseconds before? So we've written the program. Here's the AGC assembler. Not too bad. It's actually fairly understandable. And we can then compile it into a binary and launch an emulator and run it with a single button. And there we go. 5, 4, 3, 2, 1. It is now extremely easy to write programs for the Apollo guidance computer. And you can make more complicated ones. Here's a 2-player tic-tac-toe game. I am so glad that I didn't have to write that by hand. But it plays quite well. I'll play in the corner, and then the opponent will play down here. I'll play over here. The opponent will go, well, is forced. I'm forced. And now the opponent is in a no-win situation, so I'll go there, and wins, detects it, and restarts. Very simple program. So, how was it to program this in Blockly? And the answer is not the simplest. Blockly makes certain assumptions about the sorts of languages which it will generate. Buried deep in the code, I found this comment. This is in core generator TS. Technically, this should be handled on a language-by-language basis. However, all known sane languages use parentheses for grouping. AGC does not use parentheses for grouping, nor does any assembly program. I checked the Git logs to find out what idiot programmed this. His name was Neil Fraser, about 15 years ago. So, yeah. Now, I've spent months and months studying the AGC, learning how to handle all the interrupts and programming this thing, so which raises a really obvious one-word question, which is, thank you. For that, we have to go way back. Hi, my name's Neil Fraser. I run a site called Blockly Games. It is an educational site where we take students and then teach them the basics of programming, starting with conditionals and loops and variables and functions and math, and then we kick them off into text-based programming. It's very successful. We get about 3 million kids going through this every year, and we have a problem. Our problem is that about half of our students don't really understand control flow. And I've seen the same thing. I mean, I have the data for Blockly Games, but I've also seen it in previous years in code.org and anecdotally in Scratch and so on. About half of the kids don't really grok the control blocks, the loops and the if statement. And that's a real problem. For some of them, they just drop out. You can see that in the usage graphs. They just drop out as soon as you get complicated an if statement inside a loop. They're done. For many others, they don't drop out, but they just start thrashing. And I've got an example of that here. I actually watched this kid code this one in front of me. Here we go. This is supposed to be a wall-following algorithm. It's supposed to just use a couple of blocks. It's really straightforward if you think about it and then implement it, but that requires really understanding how control flow works. You can spend an hour analyzing this code and you will not be able to articulate what it does, because he just put something in here, tried it, changed it, tried it, changed it, tried it. And I'm all for experimentation, that's fantastic. But the problem is that by the end, when this thing actually finally ran, and it does run, surprisingly, I wouldn't be able to tell that, he hasn't actually learned anything. And my manager at work calls this programming by accident, but it's actually not an accident. It's evolution. You try something and you change it, and you try it and change it. And as we all know, evolution has no place in education. We want intelligent design. Context matters, folks. So, how do we get through to these people about how program flow works? And we've been trying everything for years, not just on Blockly Games, but as a community. This is a big problem. One thing that people say is, not everybody needs to be a software engineer. Okay, that might be the answer. Maybe that's just code for aptitude. Some people don't have the aptitude. That may be the case, but I would prefer to work towards a more inclusive solution. So maybe the solution isn't something new. Maybe the solution is something old. When I was growing up learning computers, we didn't have if-else, or else-if rather. We didn't have do loops. We didn't have while. We didn't have continue. We didn't have break. What did we have? Goto. Goto is the simplest control structure possible. And in fact, under the hood, everything is Goto. Goto is incredibly simple, easy to understand, and it is almost religiously avoided. Everybody knows that Goto is harmful to education. This is the original article that got the ball rolling on this. And I want to read the first sentence. This is Dijkstra. For a number of years, I have been familiar with the observation that the quality of programmers is a decreasing function of the density of go-to statements in the programs they produce. So, and I agree with that. I agree with that. Good programmers don't use very many go-to statements. People who are not very good at programming would end up in that era creating a whole pile of spaghetti. And spaghetti code is impossible to reason with. So he was absolutely right. I agree with that. But he's talking about professional programmers, not education. Let's take the same sentence and rephrase it. Instead of talking about go-to statements, we could validly say that good quality programmers use version control. Good quality programmers use integration tests and test-driven design and local scoped variables and all of those things. Great, let's throw all of those into Scratch. Is that going to make a good educational experience? No, we start simple and then move towards those things. For some reason, we have latched onto the fact that go-to statements are considered harmful, and we've eliminated them. And I think that we need to take a second look at go-to statements, bring them back into the educational process, teach them first, get people to understand how programs flow, and then move on to the more complicated structures. So, how do we get go-to statements into Blockly games? And the problem is, if I were to inject go-to statements into Blockly games, I would be excommunicated from the educational establishment because there is a near religious hatred of them. I know. So that is where the Apollo Guidance Computer comes into, because that's all it has. It doesn't have loops. It doesn't have switch statements. It's just go-tos. So this gives me academic cover to introduce a game in Blockly Games that uses go-to statements. However, in order to do this, I need help because Blockly does not have a graphical way of depicting go-to. And it should, even if you're not going to do go-to. When I click on a function call, I should really see a line going from that call to where the program execution goes to. When I click on a break statement, I should see a line showing where the execution goes to. Same thing for continue. I should see where the execution goes to. We have go to all over our code. And if we could actually visualize where this stuff is going, then that would enable us to create go-to blocks, which could make things much easier for our kids who are just getting started. There's one other consideration. It would appear, based on what I've seen, that the difficulty with flow control is preponderantly felt by one subset of our students, one demographic subset, and that's girls. My daughter is no exception. She's 10 years old. This is her creating a Fibonacci sequence in Scratch. She loves it. But she's permanently confused by if statements and loops. It doesn't flow well. I've been doing experiments on her. She's my daughter. That's what they're for. Guess what? She can read AGC assembly. What is wrong with this picture where this 10-year-old is getting confused by Scratch, but understands and can follow AGC assembly in Octal? There's something wrong here. And we can look at a graph of the percentage of graduates, female graduates of computer science in the US. Can anybody see where go-to statements were removed from the curriculum? Because I sure can. Now, correlation does not equal causation. Other things happen here. For instance, code editors got cursor keys. We forget about that. And there was also big hair. I mean, lots of things happened, but one of them was the elimination of GoTo. And now, in fairness, this graph does not show around this point, there was a huge number of hundreds, thousands of programs were started up to encourage women to enter CS. So in the interest of fairness, we should see the resulting uptick from that. Oh. Okay. So, yeah, we've tried everything else. I think we need to take a closer look at GoTos. And for that, Blockly needs to support lines so that we can implement it. With that, I'd like to say thank you. And I'm open for any questions if there's time.